friends, welcome to my YouTube channels. Today I am going to discuss the compounding, which belongs to the steam turbine chapter. So compounding, three type of compounding is there: pressure compounding, velocity compounding, and combination of these two. First we have to know what is the compounding, why we use the compounding for that. So compounding, simple concept, what is method to reduce the speed of turbine. That process is known as the compounding. So why need compounding? To reduce the velocity of the steam. So what is the difference is telling here? The expansion of the steam takes place from the boiler pressure to condenser pressure. What is boiler pressure? Suppose initially once generating the steam from the boiler, that steam pressure and energy will be very high. That if it will passes through the compounding, various type of compounding, that pressure will reduce, velocity will reduce. Why we treat this? We'll see the difference. So the expansion of the steam takes place from the boiler pressure to condenser pressure. Condenser pressure nothing but outlet pressure. The velocity of steam at exit of the turbine is very high. If expansion of steam takes place in the single stage, speed of the turbine, speed of the rotor blade will be very high. Approximately how much? 30,000 RPM. 30,000 RPM. But we know the generator steam approximately 3,000 RPM. How we know? See this? One formula is the speed of the generator is 120 into F by P. F is frequency, P is pitch. So frequency approximately our generator will be 50 Hz, 50 Hz. That is will be the 50 Hz will be the frequency, and pitch will be minimum pitch should be there, so 2. Minimum pitch should be there 2. If we substitute there 50 frequency, 2 pitch na, it's coming 3000 RPM. That is called concept of the our generator speed approximately 3000 RPM. Now, if expansion will take place in the single stage, what is the RPM coming? 30,000. The 30,000 RPM. So, if that RPM generator will run, wear and tear will take place, or we cannot control. If we will generate the electricity also, power or energy will generate, then also we cannot control. So, for that we are using the compounding. That means increase the number of stages will reduce the pressure and velocity according to our requirement. So what is that? But generator is still to increase the number of stages to reduce the turbine speed. This process is known as compounding. So now you understand the compounding. One line answer. What is method to reduce the speed of the turbine is known as compounding. How will reduce this? We are using the three compounding. What are the three compounding? Pressure compounding, velocity compounding, and combination of these two. So in this process, various method is there to control the speed of the velocity and pressure. So one by one we will discuss now what is the how the compounding is function. So before this one, the given key. If this you remember, you can velocity and pressure variations you can easily understand. Suppose let them specific volume we will talk later. First, what is in nozzle? What will the pressure? If steam pressure, initial steam pressure will pass through the nozzle, pressure will reduce. But what will be happen? The velocity will increase. The symbol is coming downward. That is velocity is decreasing. This velocity is increasing. When it passes through the nozzle, inlet of the compounding, pressure will reduce, velocity will increase in nozzle. What will be the function of the moving blade? MB, moving blade, I wrote here. Moving blade, if you see the pressure will be remain same. And what is the velocity? Velocity will reduce. Pressure will be remain same. And velocity will reduce. And this is called fixed blade, FB, fixed blade. What will happen? Pressure and velocity both will be remain same in the fixed blade. This we are discussing about the impulse turbine. Impulse turbine blade will be, see this, blade will be like this, half moon. You see the impulse blade, arc, then this is the impulse blade. If you see the reaction blade will be like this. This is profile shape, this is aerofoil shape. This is profile shape, this is aerofoil shape. You can see like this. So now we are not discussing reaction blade. Only we have to the impulse blade. This is called impulse blade. We taken the impulse blade and such like format just I kept here. So we'll see here the pressure and velocity fluctuation for the particular compounding. So first we taken the velocity compounding. So velocity compounding, what we did here, first nozzle, then moving blade, this is MB, moving blade, fixed blade, moving blade, fixed blade. So this is single stage, again double stage, triple stage. We can increase the stages according to our requirement, how much velocity and pressure we have to reduce. So now initially steam once generating from the boiler, that steam will be very high energy steam, high pressure and high temperature steam. So steam pressure will be very high initially. But initially velocity will be when initial conditions, when steam passes through the nozzle, initial conditions at approximately velocity negligible, or some very small pressure will be there, small velocity will be there, 2 meter per second or 3 meter or 4 meter per second. So just we are thinking about very low velocity, because beginning of the nozzle velocity will be almost constant, but pressure will be very high. So what is happening there? Here variation. So see here, first we will see the pressure compounding, because it is velocity compounding now. So compounding will take place from the velocity. So what is first pressure? What I told for the nozzle, pressure will be reduced. So in the velocity compounding, pressure will reduce drastically. So pressure reduces. Pressure reduces. Now moving blade, fixed blade, moving blade, fixed blade. What is this moving blade and fixed blade? Or the pressure and velocity remain same. See this, for pressure, moving blade and fixed blade remain same. So we'll draw the horizontal line. We'll draw the horizontal line. We'll draw the horizontal line. So now you see here, this is called boiler pressure. This is called condensing pressure. This is known as condensing pressure. So what is the difference? The expansion of steam takes place from boiler pressure to condenser pressure. This is called boiler pressure. Why we are telling the boiler pressure? Because steam generates from boiler, so that same high intensity steam we are supplying to the nozzle in velocity compounding. So boiler pressure converted into condensing pressure when passes through the various blades. Now what is the velocity? So velocity, any velocity means passes through the nozzle, velocity increases. So velocity will increase. Velocity will increase drastically. Velocity increases. So this is the velocity, this is the pressure, and here remains some pressure. Now velocity passing through the moving blade. Velocity passing through the moving blade, what is happening? Velocity decreases. So velocity decreases. You saw the decrease in the velocity. So this is the velocity decreases. Now again fixed blade. Fixed blade, see this, velocity and pressure both will be same. Both will be same. It will not increase, will not decrease. So velocity will be same. So this is exact horizontal line, because it remains same. Now again it will go to the moving blade. Again moving blade, you see what is happening? Velocity reduces. Velocity reduces. So you saw the velocity reduces. Again fixed blade, velocity will be remain same. Velocity will be remain same. So now you see what is there here? Velocity, loss of velocity. We can say here loss of velocity. So now this is the velocity compounding. What is compounding? Compounding you are seeing here, velocity compounding. Increases, moving blade decreases, again fixed blade remains same. Fixed blade remains same. Again moving blade, this is decreases, again fixed blade remains same. So in velocity compounding you will see the compounding of the velocity. But what about the pressure? Pressure reduces in nozzle, pressure reduces in nozzle, and fixed blade or moving blade, whatever is there, pressure will be remain same. Remain same. If you will see the specific volume here, specific volume also, sometimes they will ask you when pressure and velocity you are showing. Suppose a specific volume will be there. What is the character of the specific volume? If the specific volume passes to the nozzle, what is happening? it will increase. Specific volume, what will happen? So I am drawing the dotted line. Specific volume will be the red color. Specific volume increases when it passes through the nozzle, and specific volume in fixed blade and moving blade, what is remains same. So it will be also, you can see the variations of the specific volume. Specific volume will be remain same. This is called specific volume. It can say the specific volume. So now see this variations of the pressure. Already if you know this table, you can show this exact velocity and pressure distribution. See, specific volume for nozzle increases and both fixed blade moving blades remain same. Dotted line is specific volume. Now, if you will see this, if you will want to change the color, you can say the different color. Suppose pressure, I am going the black color. You see this pressure, first nozzle reduces. Then what is showing here remains same. What is pressure here? We are seeing all fixed blade and moving blade remain same. So boiler pressure comes to the condenser pressure. Now come the pressure compounding. If you understand this, what is the variations of the pressure and velocity, we can. So here again pressure compounding. What is there here? Nozzle is there, blade will be there, impulse blade, moving blade. Again nozzle, again moving blade, again nozzle, again moving blade. You can keep the one blade also, nothing wrong. You can keep according to the space, 2 blade, 3 blade, nothing wrong. But we have to show the variation. Here also see steam moving blade, fixed blade also known as guide blade because they are guiding the steam. Again moving blade, again fixed blade also known as guide blade. Guide. So they will guide the steam. So now see here pressure. Again nozzle first is there. Nozzle, what will happen? Pressure will be reduced. So here because pressure compounding. So slowly pressure will reduce. So it will get a lot of time to pass through the nozzle. Steam will spend the time more in the nozzle. So we'll get the constant energy. Now pressure decreases. When it passes through the nozzle, steam passes through nozzle, pressure decreases. Then what is the moving blade? Pressure will be remain same. Moving blade pressure will be remain same. Again it passes through the nozzle, again pressure will be reduces. Again it will moving blade, again pressure will be remain same. You see here, if moving blade, pressure will be remain same. But it passes through the nozzle, you can keep here reaction blade also, like you can say here reaction blade. Some books tell you reaction blade means this behaves like a nozzle. This blade is a reaction blade, so behave like a nozzle. To avoid the confusion, I have given the nozzle. If reaction blade also will be there, it behaves like a nozzle only. So we are showing the nozzle only to avoid the confusion. So nozzle, again it will be nozzle, again pressure will be reduces. Again moving blade pressure will be remains same. Now what happens? Boiler pressure becomes to the condensing pressure. Boiler pressure becomes condensing pressure. So now this is pressure compounding. So pressure, this variations of the pressure. Inclined line, horizontal because moving blade. This is the, here see this velocity compounding, velocity reduces and velocity variations we are seeing. Here what we are seeing? Pressure variations we are seeing. Now see this velocity. So already you know, if velocity will be increased when it passes through the nozzle, because you cannot cross, because it will look you keep it down only. So velocity increases. When velocity increases, this is called pressure, this is velocity. Velocity increases when passes through the nozzle. Now moving blade. What will happen on moving blade? Velocity will be decreases. So the velocity decreases. Inclined line you show that decreases. Again it will nozzle. Again in nozzle. What will happen again? Velocity. Again velocity will be increases. So increase the velocity. Velocity increases. Now again what is the moving blade? Moving blade velocity will be decreases. So decrease the velocity. Decrease the velocity. Again nozzle. Again what will happen? Velocity will be increases. Velocity will be increases. Again moving blade velocity will be decreases. Velocity will be decreases. So this also again if you show the different color it will be better. So velocity I am showing the again. Beginning itself we have to take the blue color. So velocity increases, moving blade velocity decreases, again nozzle, again velocity increases, again moving blade velocity decreases, velocity decreases, again nozzle velocity increases but pressure reduces, again this moving blade velocity reduces. So again loss of velocity we are getting. What is getting? Loss of speed of the velocity. So this way we can understand the pressure compounding. This way we can see the pressure compounding. See, pressure decreases, moving blade remains same, again decreases, remains same, decreases, remains same. But once nozzle will be there, velocity increases, moving blade velocity decreases. So this is the way to understand the compounding of pressure compounding. So this is nozzle, moving blade, nozzle, moving blade, nozzle, moving blade. So this. Now what we'll do? We will combine all two, pressure and velocity. What will happen? So from the velocity compounding you see fixed blade, moving blade, fixed blade, moving blade. Here nozzle and moving blade. Now what I did here? This is the nozzle. This is the moving blade. Moving blade. This is fixed blade. Again this is moving blade, again this is nozzle, one set, one stage. Again moving blade, you can say here moving blade, this is called fixed blade, again it is moving blade. So now if you understand the variation, now this also easily we can find out. So first you see the pressure, or here also you see the specific volume. Specific volume nozzle, what is happening? Already told nozzle specific volume is increases. So specific volume also you show this will better. So specific volume dotted line I am showing. Specific volume from the nozzle. Again moving blade or fixed blade remains same. So you draw the remain same. This line will be remain same. But again it is nozzle. Again what will happen? It will be increase. It will be increase. Specific volume increase. Again what is happening? It will remain same. When is the moving blade and fixed blade? It will be remain same. Again nozzle what will happen? It will be increase. It will be increase. Again fixed blade, moving blade. What is happening here? This blade you remove. We will draw again. So this is the remain same. What is this one? Specific volume. Specific volume. Specific volume. So okay. So here blade should be there or should not be there, not a matter. Leave it one blade. So you can show one blade also enough, two blade also enough. Okay. So this way you can see the this is inclined line. So what we'll write here? This is horizontal. Aina inclined. Horizontal. Inclined. Horizontal. So where will the horizontal? You can write the horizontal line. This is called inclined line. So you will understand this also inclined line. This is also a horizontal line. So this way you can show somewhere. So okay, now you look here. Velocity and combination of pressure and combination of pressure and velocity compounding. So what is the variation here? So similar things will be there here. First, this looks like a velocity compounding. Looks like a velocity compounding. So nozzle, what will happen? The nozzle in nozzle pressure will decrease. So reduce the pressure. Pressure will decrease. Again, moving blade, fixed blade pressure will be remain same. So moving blade, fixed blade pressure will be remain same. Moving blade, fixed blade pressure will be remain same. Again, nozzle pressure will decrease. Pressure will decrease. Again, fixed blade, moving blade, what is the pressure? Pressure will be remain same. So this is the variation of the pressure. Again, this we know the condensing pressure. Condensing pressure. Now, what is the velocity here? So nozzle, what will happen? Velocity? Velocity will increase. You change the color beginning itself. So velocity will increase when it passes through the nozzle. Passes through the nozzle, velocity increases. This is the velocity, this is the pressure. So increases. Now moving blade, velocity decreases. Moving blade, what you are seeing? Velocity decreases. Again, fixed blade, velocity remains same. Fixed blade, velocity remains same. Now again, moving blade, velocity reduces. Velocity reduces. Velocity reduces. Again, nozzle, what is happen? Velocity, again velocity increases. Velocity increases. Again, you see the moving blade, velocity, what will happen? Velocity will decreases. Again, you see the fixed blade, velocity remains same. Velocity remains same. Again, what will happen here? Velocity, moving blade, velocity decreases. So we saw the loss of the velocity here. What we are seeing here? Loss in velocity. Loss in velocity you are seeing. So this way we can see the variations of the pressure and velocity. This is called the combination of pressure and velocity compounding. So compounding, what is? To reduce the speed of the turbine blade or rotor speed is known as compounding. Now here you see the specific volume also you can show. Specific volume from the nozzle, what you are seeing? Increases. Specific volume from the nozzle, I am showing the dotted line for the specific volume, nozzle increases. Now moving blade, fixed blade remains same. So go the remains same here. Remain same. Fixed blade, moving blade, it will remain same. Again it will increase. Why? Because this is nozzle. Again increases. Give the dotted line, that's better. So increases. Now again, what is? Pressure and moving blade and fixed blade. So it will be remain same. So this is the specific volume, specific velocity, specific volume, volume, specific volume. Yes. So here what I saw? Velocity variation, pressure variation and specific volume variation. So this way we can understand the compounding. If you will watch carefully each and every steps, first you think about pressure. First you draw the pressure for all the compounding and nozzle, all the blades and nozzle. Again you go the velocity, again go the specific volume separately. So you will understand. Okay, students, watch this video, share this video to your friends so they can get the maximum benefit, and subscribe the channel so you can get the, when I will upload the video, you can get the video message for your channel. Okay, students, thank you.